Have you ever wondered how the digital age began? Dive into the 1940s, a transformative era for information technology. This was the period that marked the monumental shift from mechanical to electronic computing. During this time, the first glimmers of electronic computers began to emerge, reshaping the landscape of technology forever. Across the Atlantic in the United Kingdom, the Colossus was developed to crack encrypted German communications during the heat of World War II. This machine represented a significant stride towards electronic computing, utilizing vacuum tubes to function. Meanwhile, in the United States, the ENIAC, or the Electronic Numerical Integrator and Computer, was completed in 1945. This was the world's first general-purpose electronic computer, a marvel that was capable of being reprogrammed to perform various tasks. These machines marked the dawn of a new era in computing, demonstrating the potential for large-scale electronic computers. But how did we move from large, room-filling machines to the compact devices we use today? This monumental leap was made possible by the invention of the transistor at Bell Labs in the late 1940s. A team of brilliant minds, including William Shockley, John Bardeen, and Walter Brattain, were behind this groundbreaking innovation. The transistor was a marvel of engineering, offering several advantages over the previously used vacuum tubes. It was smaller, more reliable, and consumed less energy, making it a superior choice for electronic devices. But the transistor's significance extends beyond its technical superiority. It marked a turning point in the development of modern electronics. Its compact size and energy efficiency opened up new possibilities. Electronic devices could now be made smaller, more portable, and more accessible to the general public. The invention of the transistor was a pivotal moment in the history of information technology. The transistor was a game changer, setting the stage for the miniaturization of electronic components. So when did computers become commercially available, and how did programming evolve? Our journey takes us to the 1950s, a pivotal decade in the history of information technology. The commercial computer industry was born during this era, with the UNIVAC 1 leading the charge. The UNIVAC 1, or the Universal Automatic Computer 1, was the first commercially available computer in the United States, marking a significant milestone in the widespread adoption of computing technology. But as hardware was advancing, so was the software that powered it. This period also witnessed the rise of the first programming languages, tools designed to simplify and streamline the process of writing computer programs. Among these pioneering languages was Fortran, short for formula translation. Fortran was the first widely used high-level programming language, a type of language that is closer to human language than to machine code. This made it more accessible to programmers, allowing them to write complex programs without needing to understand the intricate details of the hardware. It was a game changer, drastically increasing programming efficiency and opening up the world of software development to a broader range of people. As the commercial computer industry took off, so did the development of programming languages, making programming more accessible and efficient. This was the birth of the software industry as we know it today, setting the stage for the technological revolution that would follow in the ensuing decades. But the journey wasn't over. How did we get to the powerful compact computers we know today? The key to this transformation was the introduction of the integrated circuit, or IC, in the late 1950s. Independently developed by Jack Kilby and Robert Noyce, the IC was a game changer. It allowed for the miniaturization of electronic components, leading to smaller, more powerful computers. The IC was essentially a complete electronic circuit, including transistors, resistors, and capacitors, all neatly packed onto a single chip. This compact design was a quantum leap from the bulky vacuum tubes and transistors of the past, significantly accelerating the pace of technological advancement. Around the same period, the Advanced Research Projects Agency, or ARPA, was established by the US Department of Defense in 1958. ARPA's mission was to ensure the technological superiority of the US military, but its impact went far beyond the battlefield. It funded a host of groundbreaking research projects, one of which led to the early development of the Internet. This project, known as ARPANET, was the first network to use packet switching, a method for efficiently transmitting electronic data that remains fundamental to the Internet's operation today. So while the 1940s and 1950s saw the birth of electronic computing, it was the late 1950s that truly pointed the way towards modern computing. The introduction of the IC and the creation of ARPA marked significant steps towards modern computing, laying the groundwork for the digital age we live in today. So, in a span of just 20 years, how far had we come? The journey from 1940 to 1960 was nothing short of revolutionary for information technology. We witnessed the birth of electronic computers, the invention of transistors, the dawn of commercial computing, and the development of the first programming languages. As we moved into the late 50s, the introduction of integrated circuits marked a significant leap towards modern computing. These foundational changes laid the groundwork for the digital revolution, fundamentally transforming our interaction with technology and setting the stage for the world as we know it.